Welcome to the MS Dev Show, episode number 206. This week we talk with Chris Lauren about ML.NET, sabotaging machine learning algorithms, generating a website from a wireframe, and the only way to win is to not play.
Raygun gives you complete visibility on errors, crashes, and performance problems affecting your end users. Replicate issues in seconds rather than digging through log files or having to rely on users to report errors or crashes. Raygun gives you a window into how users are really experiencing your software applications. Check it out today at raygun.com.
This week we have Chris Lauren. He has been a program manager at Microsoft for almost 19 years, focused on big data, machine learning, and AI the whole time. He currently leads the ML.NET team and the Azure Machine Learning PM team, which makes it possible to deploy and use machine learning models in your apps and services at scale. Welcome, Chris.
Thank you.
Yeah, 19 years, that's a long time. Microsoft has been through a couple of changes in that time.
It is, absolutely. When I first started, folks were like, why can't you answer this simple question? And I'm like, well, you didn't instrument your app, because nobody understood the importance of collecting telemetry. Yeah. And now everyone understands that data is the new oil, which is fantastic.
Yeah, absolutely. And Carl, so we're going to be shutting down all the things. What's that all about?
Not all the things, but most of the things.
Yep.
Yeah, so occasionally Jason and I get together and talk about the podcast outside of recording time. And we had some chance to kind of reflect and do that in this past week. And what we've decided is we want to put a lot of attention where things are working, and we kind of want to remove things that aren't working, a little bit of self-pruning here. So as a result, we're going to be shutting down the Facebook page. In fact, that's already done. I've already disabled that. I'm waiting for the show to go out before we turn off our Slack. So we weren't getting a lot of engagements on either of those. However,
by us either. So,
yeah,
I mean, we're part of the problem for sure.
But we're both very active on Twitter, especially Jason. I respond quicker, but he is out there creating more stuff. So what we're going to do is we're going to find more ways to use Twitter, including getting news out there on Twitter, the news links that we have. I know that was a request. I already started writing some tools that'll help with that. And hopefully we can just engage with you more often where we are all engaging together.
Yep. The reality is everybody's finding the episodes through Twitter and through the website, and obviously through subscriptions. And we appreciate all of you. So we're just making it simpler. So you'll just, we're just going to be in one place instead of 10. Yep. Or maybe 2 instead of 10 or 3. Okay, so what do we have for the comment of the week?
The comment of the week comes to us from the Swedish iTunes. So that's been interesting for us finding out how to access international comments. But this came from Alexander Hardwick. He said, MS Dev Show 5 stars, one of the best. I've been a long-time listener, reviewing now that I finally have a Mac iTunes thrust upon me, and have been enjoying the show going from strength to strength. Great hosts, interesting guests, and any podcast that hosts any host that utters the phrase, pick a number from 1 to 4 inclusive, is definitely my sort of thing.
Yeah, we had some confusion before we were doing that. So thank you for that. Yeah. So Carl found this website. It's called Chartable. It's chartable.com. And that's what let us view the comments, but we can also see our ranking in like the various countries. So I wanted to give a very special shout out to Tunisia, where we are the number 2 podcast in the software how-to category.
Way to go, Tunisia.
Yeah. I'd love to see, like, if you live in Tunisia or you were visiting Tunisia and you were listening, thank you. And if you want to send us an email at feedback@msdevshow.com, we'd love to hear about your great country. I was out there reading about it on Wikipedia. It sounds very interesting. And thank you for all your support. That's my favorite country now, I guess. Number 2. Let's get that into number 1 though. So, listeners, we need some listeners to move to Tunisia, please. So we can bump that up. Or actually you could get a friend to listen to the podcast, whichever is easier.
All right. So if you want to get mentioned on the show, like Alexander, send us an email to feedback@msdevshow.com or comment on iTunes. We really like those 5-star reviews.
Yeah, Sweden's cool too. Thank you, Alexander. I'm not putting down Sweden. I'm just pushing Tunisia up. Okay, so news. What do we got here? When AI misjudgment is not an accident, intentional bias is another way artificial intelligence could hurt us. Do you want to summarize this, Carl?
Yeah. So, I mean, a lot of times when we look at like when people use software to kind of do something nefarious, if you have access to the source, a lot of times you can figure out like, oh, this is what happened. You can kind of trace that back. But as we start incorporating more AI and machine learning into this, the way that those models are created aren't so straightforward and traceable like code is. So you could include some training data into your models that would intentionally skew the results, and that could have a huge bias coming out the end that people could intentionally do. We've already done this a lot in AI accidentally when people have done like trying to predict like what kind of criminals are going to be repeat offenders. Some of that data has not been properly vetted to take out.
Yeah, well, the existing bias goes into that data set, and that's the issue there.
Yeah, but we could use those quote learnings from what we accidentally did to intentionally influence these models for whatever we're trying to influence them on going forward.
Yeah. So for the criminal one, like I could find a whole bunch of people that look just like me that are not criminals and basically put them into the data set. That way the algorithm is biased towards saying that I'm not a criminal. That could be a malicious thing.
We know better than that, Jason.
Yeah, definitely criminal. Criminal or not. So Chris, any comments on this? I'm sure you've run into this.
Yeah, absolutely. Finding a good representative data set, or really even finding a data set at all to train a machine learning model, is a really hard problem. 80% of any machine learning problem is kind of the data janitorial services, figuring out what kind of data is good enough to use, where is my data, and then, going through the process of actually figuring out how to transform it so that it's appropriate for machine learning. And once someone has done all of that, then going through and figuring out kind of the ethics around the data, the biases in the data, is super important, but people often overlook that. And so it's a really hard problem to solve because most software engineers or even data scientists aren't really trained to understand, how to identify bias. And so this is one of the cutting edge kind of areas of research right now, as to how to kind of programmatically analyze data sets and identify biases in them, which is super, super exciting.
Yeah, absolutely. Which actually I think we should go into the next story, because I think that that's a good segue into the next story, which is how machine learning systems sometimes surprise us. You want to talk about this one, Carl?
Yeah, before I get into it, I just want to mention on this article, there's a spreadsheet attached to this article that has more examples on it. So if you think this is interesting, definitely go in there, because there's a lot of really cool things. But, a lot of times when we give machine learning a problem to solve, sometimes it solves it in ways that we do not anticipate. And this article gives a few examples. So the one towards the end that I really like, that it was given a task of not losing a game of Tetris. So the machine learning learned that if it just paused the game is never lost. So it's kind of going outside of the rule base here.
It's almost like a rage quit. I never lost.
Yeah, another one. There's this boat race game, and instead of trying to like kind of complete the course, it figures it can rack up points faster if it just spins around in circles.
Yeah, there's actually a video of that one there. I didn't even realize this spreadsheet was linked on here. This is hilarious. Like, there was a game where it figured out it could modify the game to create long legs, so it would just fall across the finish line in a race. These are pretty funny. Yeah.
Just like with anything else in life, being really clear about the definition of done or success criteria is super, super important.
Yeah.
And so just like people will find workarounds, we're getting to a point where now, the machine learning systems can find workarounds, and so we need to be really clear about what our objective is and how we decide whether a model is good enough to ship. And so paying attention to, whether it's, recommending things that we would never want to recommend on a website, for example, especially as we, get into the area of generating art or generating text and, introducing chatbots, wanting to make sure that it's only generating language which is appropriate. There are all kinds of interesting scenarios here. So it's super exciting and sometimes super scary. And so you just need to be really clear about what good enough looks like to ship.
I think this would be good for testing too, because I like this one here. Where was it? Tic-tac-toe. Evolve player makes invalid moves far away in the board, causing opponent players to run out of memory and crash. So it's just good for unit testing too.
Yeah, absolutely.
I didn't know this is like a long list of these hilarious. Yeah, the agent goes in a circle hitting the same targets instead of finishing the race. Yeah, this is pretty good. Anyway, we should move on. This next one is pretty wild. How to match A, B, C, where A plus B equals C in regex. The Beast Reborn. What is wrong with this person?
So first and foremost, this is just a huge, giant regex. I mean, I'm gonna have to quickly scroll over here, but this is just way more lines of regex than I've ever seen anybody before.
Yeah, 424 lines.
Yeah, with comments, it's 424 lines. And, I thought my regex skills were good. This guy goes by Dr. Regex. He's definitely earned his self-proclaimed title.
Yeah.
I can't even follow most of this. So if anybody can, I give you a lot of credit. But, it's one of those things where you think, A plus B equals C, let's find that pattern. This just shows how hard it is to express that via the regex syntax. Mm-hmm. We always see the canonical Stack Overflow, don't use regex for. I think this is another one of those problems. You can do it, but let's not.
Yeah, the page took a long time to load. It was linked to Regex 101, and it took a while because of all the color coding. But I think the best part was in the article he links. He said he unleashed the unholy mess onto Reddit, and I don't know if you read. Did you read the comments there at all, Carl?
Only the first couple.
Yeah, so it's loading. Here we go. So top comment, thanks, I hate it. And then the original author says, good, me too. And then the conversation continues, but I'll just leave it at that. But wow. And I can't believe this was all handwritten. That's the craziest part of this. I've seen computer written regex that does this, but this is something else. Let's see. And then the last story, wow, this AI creates a website just by looking at the wireframe. This is super cool.
Yeah. So there's a video on Twitter and it shows this camera pointed at a whiteboard. And then you can also see the monitor of what's going on. And the guy just kind of does a little wireframe of a web page. So you put a little square with an X through it for your header, and you see that he kind of roughs out a form with just boxes and lines. And it actually, as he's doing it, it identifies what it is and it creates the HTML for it. And the cool thing is it actually fills in placeholder text. It puts lorem ipsum for paragraphs. And it's all dynamic on the fly. And then as you get on in the video, there's somebody takes the website that's being generated, and it not only made the website, but it made it responsive. So the website flows properly, in a responsive way. So I think that's a really cool use of AI.
Yeah. Did you look at this, the link, Chris? It's using, you can see the machine learning, you can see the boxes around the various elements on the page.
Yeah, actually, we'd published this a while ago on our ailab.microsoft.com website. And yeah, it's pretty awesome. It's called Sketch to Code. I mean, it does exactly that. It takes your sketch and it turns it to code. Now, I don't know if you've seen, the kind of scenarios like, taking sketches and generating pictures of cats that are more realistic, and improve your art skills. But definitely taking a sketch and generating the code is pretty awesome. And there's even a tutorial on how to do that if you go to the ailab.microsoft.com. So you can check it out and play with it and generate your own website.
Well, that's really cool. I didn't even know this thing is much further along than I even thought.
Yeah.
Oh yeah, this is cool. There's a whole bunch of really cool stuff here.
Yeah, I
Oh,
did one of those a while ago from like using the Visual Studio tools for AI,
yep.
how to train your own style transfer model, for example, to make like really cool art, and so you can play with that and see how that works, and build an app using models like TensorFlow in your app. So,
Okay,
all
very
kinds
cool.
of neat stuff to check out.
Yeah, so with that, I suppose we should dive into ML.net. So yeah, you and I met. We were at dinner with some ML people, and you were talking about ML.net. I'm like, that's cool. I think people would like to hear more about that and hear some details about it. So we should probably start with the obvious question: what is ML.net?
Yeah, absolutely. So it's a machine learning framework for .NET devs to train and use machine learning models in their .NET apps. We've been using it here at Microsoft for about 10 years now, and products like Bing, Office, Windows, Azure, SQL, and more. So like if you've ever used PowerPoint and like you're typing up this really boring, status update, and like in January we did this, in February we did this, in March we did this, then PowerPoint is actually like basically watching you type, and
Mhm.
then it's inferring kind of your sentiment or your intent, like what is this person trying to do, and then it'll say, oh, like it looks like you're kind of trying to create a time tube essentially, and like it'll actually just recommend like a more beautiful and engaging layout for your PowerPoint slide in the what it's called the design ideas section of PowerPoint, for example.
Mhm.
Or similar sort of thing like in Excel, if you select a range of data and then like click chart recommendations, and it'll kind of look at what kind of data is in your range of data, and then it'll say, oh, I'll recommend this type of chart layout, for example. And each one of those actually uses ML.NET, or our internal version that we've been calling TLC for the last decade, and kind of nobody wants another three-letter acronym, so we just renamed it ML.NET when we released it as an open source. It's available in GitHub. You can check it out. But kind of wanted to be more descriptive as to what it is. It's a machine learning framework for .NET devs.
Okay, and the features you talked about too. I mean, they work better than I expected. Like PowerPoint will come pop up those designs, and I have a couple times been like, ooh, that actually looks pretty nice. I
Yeah,
click it and I'm done.
it's pretty cool, both like how fast it works, because I mean
Mhm.
it is .NET code. It can run super fast. But more interestingly, any one of those features I just talked about actually has like hundreds, if not thousands, of individual machine learning models. Like the model that actually understands that what kind of time related info looks like is very different from one that looks like, if you said in the GDP of Japan is this, the GDP of China is that, blah blah blah. It'll recognize that you're talking about different countries, and then it might actually recommend like different pictures to put in the background of the PowerPoint slide from those countries.
Oh, that's cool.
And it just really neat things like that. And so it's it's almost like a game of Plinko, where you take kind of the input data, and then it goes down in different layers in the pyramid until it figures out, oh, what's the best kind of thing I can do here, and then kind of work together with a high level kind of ranker and classifier on top to recommend the best output.
I love that
And
So
metaphor.
you can build that too.
Yeah.
yeah, so with the examples that you gave for like Excel and PowerPoint, are those models like baked into the binaries that ship with Office? Or is this something that's kind of using like some sort of service in the cloud so to kind of get that info back to us?
Yeah, that's a great question. Like, there's oftentimes things ship inside products, right? Uh, then sometimes they'll work together with cloud services. So a classic example is, for example, face recognition for tagging, for example. You don't want to necessarily send the whole high-res image to the cloud just to figure out that there's three people in the image, right? Conversely, you might have a model that runs locally, and then it'll do some kind of initial processing to say, oh, I found three people in the picture. Get get the bounding boxes of those three faces, and then send those faces to the cloud service to then kind of match and figure out who the person is to tag them, for example. So it's sending a minimal amount of information up to the cloud at that point. And so depending on the services, like for example, the Windows Hello login, where like security is super important, those things run locally on the machine, don't use cloud service. But then other things like the PowerPoint Designer, a lot of that actually does run in the cloud.
So when you do have those kind of like multiple models that it gets processed through, does ML.NET help you kind of chain those two together, or do you have to kind of like manually stitch the output of one into the input of the other?
So for everything in ML.NET, supports a notion of what we call pipelines, whereby whether it's say pre-processing, like oftentimes you might to train a model, you might do convert an image to black and white. You might resize it to a certain, say, whether it's 28 pixels by 28 pixels or something larger. There's a number of steps that you do like before you actually score the model. And oftentimes using other machine learning frameworks like Python, people will kind of store that pre-processing code kind of separately from the trained model itself. And then when there's a handoff from like a data scientist to a dev, some of that pre-processing code like doesn't get passed along with it. And then the dev is like, what do I do with this thing? And so the way ML.NET works is whether you're pre-processing data or using other trained models as part of your pipeline to stitch multiple models together, it works the exact same way. And so you always have like this kind of pipeline construct whereby you can add things to it. And whether you're adding data transformation steps to it or adding other trained models to it, it works the same way. And then all of that gets saved in one zip file that is the encapsulates the model and all of its information and all of its pre-processing code, so that then when you invoke the model or call the .predict method, then all of that stuff just happens. So you don't have to write separate code to do that in some particular order. Does that make sense?
Yeah, and so it's more of the architecture lends itself to give you all of that kind of, no matter if you're combining them or not.
Yeah, exactly. And so, we very much kind of orient this to, the person who trains the model doesn't necessarily have to be, the person who uses it in their app, because oftentimes, big teams work together and stuff. And so we want to make using the model as simple as possible and as performant as possible. And so you just, once you have the zip file, then you can just use that in a bunch of different applications. A bunch of different people can use it and get consistent results.
Don't wait for users to report problems. Raygun gives you complete visibility on errors, crashes, and performance problems affecting your end users. Replicate issues in seconds rather than digging through log files or having to rely on users to report errors or crashes. Raygun gives you a window into how users are really experiencing your software applications, supports all major programming languages and platforms, and integrates with your current development workflow tools too. There's a free 14-day trial, and it takes minutes to implement, so start resolving issues in your application and check it out today at raygun.com.
I mean, I'm sure there's lots of features in ML.NET, but like what kind of things does it do?
Yeah, absolutely. So, at a super high level, any machine learning framework is basically going to enable you to train machine learning models and then use them in your apps or services. And ML.NET's no different. But, it's important, to, clarify, like, what is a machine learning model?
Right.
So it's easy to think of a machine learning model as basically like an intelligent library that you add to your app. Like, people have used libraries to say generate PDF files, for example, and you're like, I don't know what's inside that library, but I just know I give it some input, and then it'll emit a PDF or it'll emit an image, and it's like, okay, great, it just works. And so a machine learning model is just an intelligent library that takes some input and produces some output. But ML.NET enables training machine learning models for more of what's called traditional machine learning. So scenarios like predicting the price or the capacity that's required to run your service, for example, or so that's called regression type of scenarios. It enables clustering, like taking in a bunch of data about your customers, maybe their purchasing habits or whatnot from an e-commerce site, and then grouping them into different customer segments that you might then want to target for either promotions or for different scenarios. It enables anomaly detection, so like you can collect metrics over a period of time, say for resource utilization or for credit card fraud. Just identifying any kind of anomalies in your data, and also doing recommendations. So like if you've got an e-commerce site and you want to recommend products that the customer might like, either based on what they're currently looking at or based on past purchasing habits, or re-ranking, like the search results in Bing or Google, or re-ranking in a product catalog to again try and get the maximum sales on your e-commerce site.
Yeah.
So that's just a couple of scenarios.
Yeah, in my mind, there's like two like big categories of ML things to me, and I'm an ML newbie, so that this is probably not how everybody else thinks about it. But there's like these mathematical formulas where I looked at some of the ML.NET code, and I know you can do some of that. And then there's this other category that I think of, which is like this these high level abstractions, right? Which is really like Azure Cognitive Services. You can say, here's a photo, look for the things that are in it. So I saw like kind of the lower level function type stuff in ML.NET. Are there also like higher level abstractions built in there where if I'm not a machine learning expert, I can maybe, actually train a model myself on some image, basically give it some labeled images and say, here's how you look for raccoons. And then actually like operationalize that and say, hey, does this image have a raccoon in it?
Yeah, you absolutely can. For some of the scenarios like image classification, we usually rely on kind of pre-trained models that are available in, say, different GitHub repos or in model galleries using whether it's TensorFlow or ONNX, which ML.NET integrates with. And so you can achieve some of these more interesting scenarios using complex data types like images or audio. And you can, using your .NET code, then take your input image, you can pass it through that deep learning model in that case, and then determine does this have a raccoon, yes or no, or where in the image is the raccoon,
Yeah.
and get the bounding box type of information back.
Yeah. So are you sending that off to TensorFlow or ONNX, or are you actually then using the model to figure out if there's a raccoon in it?
Yeah, so our architecture is very extensible, and so we have basically a bunch of different NuGet packages, depending on what kind of scenario or what you want to do with it. And if you want to include ONNX models or TensorFlow models, then you add them like Microsoft.ml.TensorFlow NuGet package, for example.
Okay.
And under the hood, then that includes the TensorFlow runtime automatically. And then you can, when you include your TensorFlow transform, then it invokes TensorFlow. So you get the full power of TensorFlow in that case, or the full power of the ONNX runtime, just from an easier to use .NET interface.
Okay, cool.
And then again, you can stitch together multiple of them together. So, if you're familiar with like machine translation scenarios where, we're speaking to each other, but if you were speaking Japanese and I was speaking English, like one of the first steps people might do is like audio signal cleanup, or they might determine, are you indoors or outdoors? And then kind of, clean up the noise in the audio signal, and then do, say, the speech to text translation or the speech to speech translation. And so again, it's that model ensemble, that game of Plinko, where you stitch multiple of them together. And so this would, again, in this case, take a couple of models, stitch them together in the ML.NET pipeline, no matter whether it's ONNX, TensorFlow, or ML.NET models themselves.
Cool.
So I'm a pretty strong .NET developer, and ML.NET kind of makes sense for me looking into getting started in machine learning. But pretty much everybody that I know that actually does ML for like a day job knows Python. It seems like they're writing Python daily for that. If we have that kind of person out there, is ML.NET interesting for them?
It's possible. Python is fantastic. I mean, I write both .NET and Python daily, which is always super exciting when going back and forth mentally switching. But the thing is that if you're more of like that data science, hardcore data scientist, loves Python, working in Python all the time, and you're ultimately just going to put your machine learning model like in a Docker container with the REST API, and that works for you, like great. Like there's kind of no real reason to switch. I mean, Microsoft is open and interoperable. You can use any language you want to train machine learning models and deploy them using, say, Azure Machine Learning. We'll even auto scale your Kubernetes cluster for you, blah, blah. Like we fully embrace open source stuff, and ML.NET is open source. Now, the question then becomes, where are you going to deploy your model? If you're going to put your model into a .NET app, for example, then taking, say, a scikit-learn model and putting it in a .NET app, super hard. Right? There's kind of two ways to do it. One way, you could convert it to a common intermediate format we call Onyx, that we partnered with Facebook and Amazon to actually create as a new industry standard model format. Or you can start your model from scratch using either, say, Nimbus ML, which is the Python bindings we created on top of ML.NET. So if you love Python, you can still use ML.NET under the hood to train your machine learning model. And the reason why you would want to do that is because then the model format that it gets saved in can be used natively in a .NET app. And that makes it really easy for a data scientist to hand off the model to the .NET dev to include in their .NET app. Mm-hmm. But if you're a .NET dev just building .NET apps and you want to get started with machine learning, then it makes sense to like not have to learn machine learning concepts like the difference between classification and regression, etc., and learning a new language at the same time. That makes it really hard.
That's exactly what I was going to ask. Like, do I need to learn Python to use this, or can I just stick with .NET? It sounds like I can just stick with .NET.
Yeah, if you're a .NET dev, you stick with .NET. That's going to be the easiest, and that's why we released this, is because there was really nothing out there that was really good for .NET devs, and we've been sitting on this for years inside the company, and we wanted to release it as open source and just see if the community actually likes it, and create it in the open and see what happens.
Yeah. Now in Python, there are a whole bunch of really nice machine learning libraries that exist. This isn't my thing, so I don't know what they are. But whenever you start talking to them, like I have looked at like Keras and like some other. I'm sure there's like a whole host of Python libraries for doing machine learning. So is there a way you mentioned before? I think sort of interoperating. Can I use some of those Python libraries, and can I go that direction or not?
Yeah, you absolutely can. So for example, like our Python bindings on top of ML.NET actually fully interop with Pandas and scikit-learn.
Yeah,
for
those are some of the ones that I've heard. Yeah, okay.
Yeah, and so basically you can use like Pandas for your data prep and kind of data wrangling that people do, and then you can even use inside of a scikit-learn pipeline, you can even replace some of the components, just like if you want to replace the principal component analysis or the n-gram featureizer or whatnot with the ML.NET implementation of the same thing using the exact same API. So you don't even have to learn new code. You just replace your import statement, and then it'll get you a speed up of like 5 to 10x. Which, I mean, who doesn't want faster? Mm-hmm. But then also, because ML.NET supports reading and streaming data, so if you've got more data in your training data set than fits into memory, ML.NET can do that. But like scikit-learn by default does not. And so then you would have to figure out a way to train on more data using these frameworks, and it's really hard. And more data always beats better algorithms when you're talking about machine learning.
Mm-hmm. Cool. And then what about cross-platform? Does this work anywhere? Can I use it with .NET Core?
Absolutely. I mean, it's amazing how many people I talk to that still kind of have this weird association of like, oh, .NET is a Windows thing. And it's like, no, that's absolutely so not true. You can use ML.NET on Linux, on Mac, in Docker containers. And yes, of course, you can use it on Windows too. But because we're actually .NET Standard compliant, so you can run it anywhere that .NET runs.
Okay. Well, that's
Which is
cool.
anywhere, right?
Yeah.
Which is there's very few places that it doesn't run. And like right now, like we just added x86 support in our last release, and we're still working on getting, say, like, ARM32 to work. So for super small IoT type devices, we're still working on that, but that'll hopefully come early next year.
Okay.
So do you have any like examples where I can just kind of go download and just kind of just watch it run to see how this kind of all works?
Yeah, absolutely. I mean, there's a lot of people really, before they even want to go and read books on stuff, they want to just like get their hands on the code and kind of look at it and try and wrap their head around it and play with some samples. And so we have a whole GitHub repo dedicated to just samples. And that's at GitHub whack.net whack machine learning -samples. And you've got samples there for, like, say, GitHub issue classification. So like if you create GitHub issues on the .NET Core FX repo, we automatically triage those issues and add tags and labels to those issues. And so we provided a sample of how to do that. We also have samples for credit card fraud detection and customer segmentation and image classification using TensorFlow. So figure out whether the image has a dog or doesn't have a dog, or has different types of fruits in it. There's those kinds of samples. And customer like comment sentiment analysis. So determine whether the sentiment is positive or negative, toxic or non-toxic. So there's a whole bunch of different samples on a repo.
Yeah, I see there's quite a few out here. That's pretty cool. So what features are missing, and like what is planned on the roadmap, if you can talk about that?
Yeah, absolutely. One of the features that we're adding right now and will be in our release the first week of December. So we have monthly releases the first week of every month. And so one of the ones that we're adding right now is called model explainability. When looking through traditional code, if you will, understanding why the function or method performs a certain way is pretty easy, because you can kind of step through it, right? But with these machine learning models, depending on what type of data the model was trained with, it'll perform very differently. You can use the exact same code to train the model, but if you have, say, you're building an image classifier and your training data has a bunch of pictures of fruit, for example, versus a bunch of pictures of different kinds of people, then you're going to get very different results. And so trying to understand why a model did a certain thing, whether it predicted whether the sentiment is positive or negative, etc., is very hard to understand. And so we're adding features to enable kind of the better kind of debugging and understanding of why a model performed the way that it did. We're also actively working on a UI tool that'll be available through Visual Studio, and so you can like file new machine learning project essentially. And that's super important, and been one of the keys as to how this machine learning framework has become popular and useful inside Microsoft. Is we've had a UI tool that enables kind of specifying what kind of task you want to perform, and then kind of automatically it'll walk you through some recommendations on how to work with your data to achieve your best outcome, and kind of generating the code to train the model and compare different ways of training the models against each other, because it is science after all. It's data science, and the scientific method really is guess and check, right? And so there's more than one way to kind of achieve the same task, and so oftentimes you'll want to try a couple different ways and compare them. And so having a UI tool to do that can really accelerate productivity. But of course, all the features are still available from a code first kind of easy to use SDK, but that'll be there.
Yeah, I was just looking through the samples. Like I see the binary classifier to figure out whether or not it's like a positive or negative statement. like this code, I mean, this is pretty simple. So I think this is pretty cool. Like it's pretty simple to train, and it's pretty simple to actually use it. So yeah, I mean, if you're a .NET developer and you need to do something like this, this is right up your alley. I like this.
Yeah, we have kind of a charter to make sure that every developer, whether they're a Python developer or a .NET developer, can use machine learning and infuse intelligence in their applications in the cloud and on the edge. And so we just want to make sure that all the folks that are super passionate about .NET can really grok this and add great capabilities to their applications and just make them modern. And because our customers expect that these days. Machine learning and AI is all around us, and we just want to democratize that and make it possible for everybody to do this.
Very cool. Anything else you wanted to mention?
Not really. I mean, I want to reiterate the fact that, because this is an open source project, we would love for the community to file new issues or, create new samples. We would love, more engaging, interesting samples that are fun or, maybe have some real world kind of business value. And if you want to, contribute new algorithms, there's so much more to do in this space. We're really just getting started, and so we would love your help and I love your feedback.
Super cool. Just give it a try, people.
Absolutely.
Okay, and then Carl, what do you have for the Azure pick of the week?
So the Azure pick of the week this week is the Azure portal itself. Mm-hmm. And more importantly, for the account manager up in the little corner, a lot of times if you were to have like a work account, a personal account, or maybe you're a consultant, so you have multiple work accounts for each of your clients, like if you went and logged in to get to the other one, you had to fully log out completely on your browser or have tabs open or incognito mode. I mean, it gets messy how you want to manage that. But now you can have multiple accounts where you can just swap to another account directly in the portal without having to log out, without having to reload. Mm-hmm. So that's definitely a huge productivity boon for the portal.
Yeah, I see a lot of people that are using incognito mode, like you mentioned, and use Chrome profiles or use this feature. Like this feature solves it, I think, for a lot of people. But Chrome profiles let you go even further and actually, have totally different logins for things. So very cool. And then website of the week, Carl?
Yeah. I follow Ryan Loudermilk on Twitter, and he had a link to a web page that has all sorts of free wallpapers that are pretty well done. A lot of Microsoft theme ones called wallpaperhub.app. So these are really high res, just gorgeous images. If you need some wallpapers, go check it out.
This is cool. I like the Windows 10 Bliss. It has the old XP background in it. Yeah, these are pretty nice. Yeah, that's a very cool site. Okay, cool. And then you have 2 dev tips of the week.
Yeah, so the first one is a Twitter list from Jen Gentleman. She's works on the Windows Insider team. She keeps a Twitter list of helpful hotkeys. So go there, check it out if you just want to check out a bunch of Windows-oriented hotkeys. And she sometimes even has stuff for Office. So a lot of really cool, just different shortcuts, keyboard shortcuts to do all sorts of different things on Windows.
Okay.
And then specifically, I knew about this one, but Scott Hanselman also tweeted about this recently. In the most recent version of Windows, so you have to have Windows 10 1809, there's now a built-in clipboard manager. So if you hit Win-V instead of Control-V, you can see basically the last many things that you copied into your clipboard, and you can select any one of them. So instead of having to copy, go over, paste, go back, copy, go back, paste, you can just hit copy, 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 and go over, hit Windows V, and paste the specific ones you want in the order that you want. And it syncs across devices. So I think it uses either Edge or Cortana on iOS. And then if you have the Microsoft launcher on Android, that's built in there.
Okay. That's very nice. I mean, I like that implementation. Okay, so Chris, there's a game that we play on this show. What I need you to do is pick a number between 1 and 2 inclusive. We're running out of numbers. Which one would you like?
I'll choose number 2.
Number 2. Would you rather spend a full day with a bad grass, it's in quotes, with a bad grass itch from lying on the grass in shorts, or spend the day trying not to scratch 15 scabs that itch like crazy and are just starting to peel off?
I'm going to go with the bad grass itch myself.
Yeah, I think so too. It's a full day. Spend the day. Either way, you're spending the day.
Yeah.
Okay, so here's another side benefit to picking the first one. This is end of fall, beginning of winter right now. So that means that you're on the grass and it's nice enough to be outside.
Totally. And I don't have a bunch of scabs that people have to stare at, so I mean, it's like, I don't want to go to a meeting and be like, what is this guy, a leper? It's like, I don't know.
Yeah.
I'll take the grass itch. Totally.
Okay. So I think we're all in agreement there. Very cool. Okay, and let's see. Where can people find you, Chris? It looks like Carl he's collected a whole bunch of links that you've mentioned. We'll include those in the show notes. But where's the best place for people to find you?
Generally on Twitter, CLauren42.
Okay.
So it's CLAUREN 42.
There you are. Very cool. And Carl, where can people find you?
You can find me on Twitter at Carl Schweitzer.
And you can find me at ytechie.com or on Twitter at twitter.com/ytechie. Chris, thank you so much for coming on here and talking to us about ML.net. What a cool technology.
Absolutely. Thanks for having me, guys.